Okay, we are going to be looking at how we can compound vectors here. By compounding vector, we mean how we can sum vectors, add two vectors acting on a body. So we are going to look at that in several ways. So we are going to look at how we can add two vectors when they are moving parallel to each other. Then we look at how we can add vectors when they are moving in opposite direction and parallel or anti-parallel direction. Also, we will equally look at when two vectors are acting at an angle 90 degrees, or what we call perpendicular to each other. Then finally, we look at when two vectors are acting at an angle which is not 90 degrees. So all these are various ways we are going to be looking at how they are going to be getting their resultants. So we are going to be looking at the resultants of these forces. But first of all, what do we mean by vectors? Vectors are quantities that we can fully define when we state the magnitude of that vector and then the directions. So for us to represent vector, we normally use a straight line with an arrowhead. So in this topic, we are going to look at how we can compound two vectors or add two vectors that are acting at a body. So take for instance, when two forces is pushing this car. So the 3 Newton force is pushing the car alongside with the 4 Newton forces. So when you look at it, they are actually moving in the same direction. They are pushing in the same direction. So how do we compound them? How do we get the resultant? So we see that the two forces will combine to have the resultant. And that is why we are adding that the resultant is 3 plus 4. And that gives us what? 7 Newton. Okay, so that is when we combine forces. So most of the things that we actually work out, like lifting something and all that, we use this method. Now, when we look at two forces, when they are now pushing in opposite direction, so they are equally parallel, but this time anti-parallel or counter-parallel. So when you are pushing forward, another is pushing in opposite direction. So the resultant force is actually the difference in the magnitude. So the bigger one will actually push the smaller forces. So and that is why the resultant force pushing it is the difference in their magnitude. So and that is why when you look at the 4 Newton force here and the 3 Newton force is pushing. So the resultant force is going to be 4 minus 3, and that gives us the resultant. Again, looking at two forces acting perpendicular or at right angle to each other. So how do we compound the forces acting on them? So we use the Pythagorean theorem or Pythagorean rule to solve it. So, and the Pythagorean rule is basically the square root of the sum of the square of the two forces. So, and that's what we have represented here. 4 square plus 3 square, we take the square root, and that gives us the resultant force for that vectors. Now, finally, what if the two forces are acting at an angle other than 90 degrees? So how do we compound it? So we use what we call the parallelogram law of vectors, which states that when two forces are represented in magnitude and direction by the adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal of that parallelogram drawn from the point of intersection of the two vectors. So, and that's the principle we are using here. And then we use the cosine rule in determining the resultants. So these are the basic things that we need to understand before